Hey guys, welcome back to another video. Today I'm discussing basics of functions. And so I am going to start off with some vocabulary, some terminology. Starting off with a relation. A relation is basically a set of ordered pairs. Remember, a pair contains two elements, guys. When we talk about a relation, we typically use a capital letter to name a relation. So here's an example of a relation, guys, with some points: 3, 2, 1, -1, 2, 0, and perhaps let's go ahead and do 0, -1. I'm just making this up as I go along, okay? So here's your relation right here, relation A. We call it relation A, guys. Now, remember, this is a set. A set contains two items, just like a pair contains two items. So in a relation, guys, it's a set of ordered pairs. So there are two set of elements. The first set of elements is referred to as the domain, your x's, the x's in a relation. So this is the first set of elements, guys, in a relation. Now, of course, we can say also all the x's, okay, whatever the x's in that relation are. Next, we've got the second set of elements, which we refer to as the range. The range references the y's, okay, guys? This represents the second set of elements in a relation. All right. So guys, essentially you got two sets of elements. You got the first set, which represents your x's, called the domain. Your second set of elements, which represents your range, okay? Which represents all the y's in that relation, okay? AKA the range. Now guys, listen, this part right here, the majority of it has to do with verbiage, terminology, okay? So let me go ahead and address one more item, and then I'm going to go ahead and move on. Every once in a while, you will see this notation right here, the letter referencing the relation with a -1 power. This is expressing the inverse of a relation, the inverse, okay? So when you see that -1 power here, guys, they don't mean to take the reciprocal of it. They mean to find the inverse of the relation, okay? So here, if we're looking at the inverse of a relation, basically we're just swapping. We're going to swap x and y. Now, I'm going to mention this just this time. I'm not going to mention it again because we're going to save this for the higher level math courses. And so if we were to be given, guys, a relation like the previous one, we had relation A, which had the elements 3, 2, ooh, I hope I didn't forget them, okay, 1, -1, then I had 2, 0, and I think I had 0, -1. I think that's what the relationship was. Now, if I were to ask you to find the inverse of this relation, guys, all we're doing is swapping x and y. So x becomes y, y becomes x. When we find the inverse of a relation, we're swapping x and y. So the inverse of this relation would be 2, 3, -1, 1, and then 0, 2. Last but not least, -1, 0, okay? This would be the inverse of the relation. All right. Now, guys, we're going to head back to relation A. If I were to ask you to find the domain, remember that's the x's, of relation A, what would be the domain of relation A? Remember, The domain represents all the x's. So if we go back into relation A and pick out the domain elements, that would be the 3, the 1, the 2, the 0. By the way, guys, if you have a repeated element, you can only use it once. So if we were to go into the range and I were to ask you for the range of this relation, the range of this relation would be 2, -1, 0, and that's it. Now, why is that? Because, guys, I don't know if you noticed, this -1 right here is a repeated element, so we can only write it down once. So when you have a repeated element, make sure you're writing it down once. Now, before we move on to the next part of this, guys, let me just say this. When we talk about the XY plane, the coordinate plane, the XY plane, you know, this is your XY plane here. This is quadrant 1, quadrant 2. This is your vertical axis, the y-axis. Your horizontal axis is the x-axis. When they intersect at this point called the origin, and the coordinate of the origin is 0, 0. Now, obviously, once the x and the y-axis intersect, they create these quadrants, okay? And quadrants are basically just regions, okay? So they create these 4 different regions. When we name the quadrants, we name them using Roman numerals going counterclockwise. So that's why I'm starting top right with 1, top left with 2, bottom left with 3, and then bottom right with 4, okay? Now, when you plot a point in the first quadrant, both x and y are positive. When you plot a point in the second quadrant, guys, x is a negative, y is a positive. When you plot a point in the third quadrant, both x and y are negative. And then finally in the last quadrant, x is positive, y is negative. It's good to know this information. Remember, guys, math is all about building on the foundation too. As you learn, we just keep adding more to it, okay? So we're just adding to the foundation. All right, so why in the world am I presenting all of this to you? Here's why, guys. Listen, when it comes to plotting a point in the XY plane, it's always in alphabetical order. Think about alphabetical order, guys, okay? Alphabetically. So if you're not sure which one is which, think alphabetically. Domain versus range, okay? Which one comes first alphabetically? Domain comes before range. So domain would be synonymous with X. Range comes after domain. So range would be synonymous with the Y. Likewise, guys, if you were to encounter horizontal versus vertical, okay? Now think about this, okay? Horizontal versus vertical. Alphabetically, horizontal comes before vertical. So if you look at the XY coordinate, horizontal has to do with the x-axis, while vertical has to do with the y-axis, guys. You see the alphabetical order? Okay, eventually we're going to get to this term right here, input versus output. Alphabetically, which one comes first? Input comes before output. So X has to do with input, Y has to do with the output. Guys, do you see how it all coalesces together? I mean, to me, this makes perfect sense, okay? So you should be getting the drift of this. I'm going to mention just one more, and then I am going to move on from this, guys. And this one more that I'm going to mention, I'm going to drop it in a different color because some of you have seen this already. Maybe you didn't make the connection. So let me make the connection for you. Cosine versus sine. Alphabetically, which one comes first? Cosine comes first. So cosine is synonymous with X and sine is synonymous with Y. Guys, think alphabetically when you are in the XY plane. By the way, while I have this table on here, one more thing I need to say. A negative times a negative in the third quadrant, positive. I have positive times a positive in the first quadrant, positive. So guys, if you draw a line going from left to right, positive slope. We're going to be talking about slope too, but I wanted to mention that here while I have the XY plane. Okay, now in the second quadrant, negative times positive, negative. In the fourth quadrant, positive times negative, negative. So if you draw a line going from left to right that falls to the left, to the right, negative slope, guys. I know. I know, okay? So guys, we'll be talking about that some more later on, but let's get back to the business at hand, which are the relation, guys. When we talk about the relations, a relation can be expressed as an equation. It could be an equation, something like y is equal to 2x plus 3, okay? It could be a set of points like you saw earlier. It could be a graph, you know, where we go on the XY plane, we go ahead and plot some points on the XY plane here. Let me drop some points on this XY plane using a different color here, okay? So if I were to drop these points on here, this would also represent a relation, guys, okay? And so another way is a table of points, a table of values, guys, x comma y. And so you might have something like this: 3 comma 2, 1 comma negative 1, 2 comma 4, 3 comma 0. That's another way to express a relation. And then last but not least, another way to express a relation is through a mapping. This is where you're going to organize your domain and your range, guys. The domain goes first over here, the range goes second. So when we talk about the domain and the range, guys, you might see something like this. Here's your domain with 3, 1, 2, 0. And then your range, remember the range from earlier, might have 2, negative 1, 0. And then what you have to do is show which element in the domain maps to which element in the range, okay? So the 3 is paired with 2. The 1 is paired with negative 1. The 2 is paired with 0. And 0 is paired with negative 1 as well, okay? So these are the various ways a relation can be expressed, guys, when we're expressing a relation. So various ways to express those relations. Now, moving along, guys, here's a big definition, big vocab word, and we're going to be using this consistently. So be comfortable, try to be comfortable with this, okay? A function is a relation, okay? Remember, we just talked about a relation, set of points, a graph, an equation, a mapping, okay? A table, okay? It's a relation where each element, number, you could call that, okay, in the domain. And remember, the domain represents your x's or your inputs, is paired with one element in the range. And remember, the range has to do with your y values. Okay, guys, so what in the world am I talking about? So if you're given a relation, to determine if a relation is a function, you look at your domain. As long as the domain is paired with one element in the range, it's a function. In other words, in order for it to be a function, the domain cannot repeat. In order for a relation to be a function, the domain cannot repeat. In other words, your x's cannot repeat for it to be a function. For every x, there has to be one y element. For every x, there has to be one y element. Okay, so what in the world am I talking about? So we're going to go back to relation A again. Remember, relation A had the following points, guys. 3 comma 2, 1 comma negative 1, negative 2 comma 0. Oops, what happened to that 0 there? Okay, and then 0 comma negative 1. Now, guys, we're looking at the domain, just the domain. Okay, your x's, look at the x's. Do you look at the x's? Keep looking at them. Is anything repeating? No. So when this comes up, the question will come up, is the relation a function? So looking at the relation here, the x's are not repeating. Therefore, it is a function. Yes, it's a function, guys, okay? It's a function. And just like that, you're done. Once again, look at the x's. As long as the x's don't repeat, guys, it's a function, okay? We are not looking at the y's. Don't worry about the y's. We're looking at the domain, guys, okay? So here goes another part of this, guys. What if you're given a graph? Given a graph, you have to determine if it is a function. You have to determine if it is a function if you're given a graph. So when you're given a graph to determine if it is a function, we're going to perform the vertical line test. Remember, guys, in order for it to be a function, the x values cannot repeat. The vertical line has to do with the x values. So when I can't write all of this down because I'm going to run out of room. But when you perform the vertical line test, guys, you draw a vertical line. I'm going to demonstrate this in a minute. You draw a vertical line anywhere on that graph, anywhere on that graph, as long as that vertical line intersects, touches the graph once, it's a function. A vertical line drawn anywhere on the graph can only intersect the graph in at most 1 point for it to be a function, 1 point. So what in the world am I talking about? Let me give you some quick examples, guys. So once again, if you draw a vertical line and on a function, in order for it to be on a graph, in order for it to be a function, the vertical line can only intersect the graph in at most 1 point. So guys, here's a graph. By the way, this graph right here, I wonder if you guys know what it is. Take a guess. What do you think? Okay, I'm going to tell you. It's a parabola. How many of you got that right? Okay, so here's a parabola, guys. If we were to draw a vertical line anywhere on this graph, guys, every time we draw that vertical line, notice that vertical line is only intersecting the graph once and only once. So therefore, yes, this is a function. Now let's try another one. This one is an absolute value graph, okay? So when you draw, let me grab a different color. When you draw a vertical line anywhere on the graph, notice that vertical line is intersecting the graph once and only once. So yes, this one is a function. Let's do it again. This time, let's do a circle, guys. We're doing a circle. Anywhere, anywhere, anywhere. I draw a line. Notice what's happening. It's intersecting the graph more than once. So therefore, this one is a big fat no. This one is not a function, okay? Now, every once in a while, you do get some ambiguous ones. Look at this one right here, guys. Okay? Remember, that vertical line must be drawn anywhere. So if I draw it here, that's once. If I draw it here, that's once. Over here, that's once. But guys, look at what happens. It has to be drawn anywhere on the graph and intersect the graph once for it to be a function. So is this one a function? No, this one is not a function, guys. Definitely not a function, okay? So given a graph, to determine if it's a function, we perform the vertical line test, guys, okay? Now, here's the next part of this, guys, talking about the function notation. Function notation is big in mathematics, and once you learn it, you will always use it. So for function notation, guys, function notation pretty much does this, guys. It basically tells you, okay, it indicates, let me say it this way, it indicates the independent variable. It's indicating the independent variable that the equation depends on, okay? What in the world am I talking about? Let's say we have the equation y equals to 2x plus 3. Now we know when we have this type of equation, if we want to find points on this graph, what are we going to do? We're going to plug in values. We're going to input values for x and find the corresponding y values or the outputs for y. So basically, this equation, we could say y depends on the value of x. So in order to show this, guys, we're going to take this equation and rewrite it as a function, okay, as a dependent of x. So rather than having y here, we're going to rewrite it as f of x is equal to, and it's still the same equation. So what do you notice is the difference between the two? F of x replaces y, or y replaces f of x. So essentially, guys, f of x is the same thing as y. F of x is y, and y is f of x. So if you're not comfortable with function notation, you can continue using y, guys, until you feel comfortable using function notation. It really doesn't matter. Now, when we talk about function notation, guys, the most common function notation you will notice besides f of x would be g of x, h of x. These are the most common, okay? But you can create function notation with any combination of variables, guys. For example, distance versus time, d of t. Yeah, that's function notation, okay? This distance is a function of the time that you've been driving for, okay? You could also do speed too, so whatever. Okay, now guys, listen. For function notation, we are going to continuously use it. So get used to the fact that y is the same thing as f of x, or f of x is the same thing as y, okay? Now, next part of this, we're going to be evaluating functions. We're going to be evaluating, oops, I wrote the wrong thing, evaluating functions. Now, when we are evaluating functions, you are given an x value, which we refer to as the input, and your job is to find the corresponding, I'm going to abbreviate this, corresponding y value, which we refer to as the output. Okay, we refer to it as the output, guys. So evaluating functions, very easy, but you got to know what you're doing, guys. So what I'm going to do now is go ahead and go through some various examples with you. And as we do this, guys, keep in mind when you get to the classroom, I am going to be going over these as well. So if you don't fully get it, you can ask questions in the classroom, okay? So guys, here's the first one. If we have f of x is equal to 3x plus 5, and I want you to find f of 0, f of 1, and then f of negative 3, okay? Remember, this represents your x value. That's your x value. That's your x value, or your input. You're going to take that 0 and go back into the function and input it for x, as in substitute the 0 in for x. Replace the x with 0, guys, and then work it out. So once you plug it in there, you just do the work. 3 times 0 cancels out, leaving you with 5. So you input 0, the output is 5. So f of 0 is equal to 5. When x is 0, the function is at positive 5. The function is equivalent to 5. Let's do it again, guys. F of 1. This time, we're going to go back into the same function. We substitute 1 in for x, and then we're going to work it out. 3 times 1 is 3. 3 plus 5 is 8. So we input 3, and the output is 8. The value of the function at x equals to 1 is 5. Now, let's do it again, guys. F of negative 3. So we're going to do 3 times negative 3 plus 5. 3 times negative 3 is negative 9. Negative 9 plus 5 gives you negative 4. So when you input negative 3, the output turns out to be negative 4. So the value of the function at x equals to negative 3 is negative 4. This is what I call evaluating functions. All I'm doing, guys, is plugging in those values into the function and working them out, okay? These values right here, I'm just plugging them in, okay, and then working it out. What function am I plugging in? I'm plugging in them right here, okay? That's all we're doing, everybody. All right, so that was the first example. Let's do another one. This time right here, it's a little bit more complicated, guys. Let's see if you can keep up with this one, okay? Ooh, that's challenging, okay? Let's give it a try. So we're gonna find f of 0, f of 1, f of negative 2. All right, guys, so let's do it just like before. We're going to plug in 0 wherever we find an x. So negative, and then we're gonna plug in that 0. Here, let me drop the 0 right there, okay? So that's squared. And then we're gonna come over here and plug in 0 again. Oops, let me use a different color, okay? So I can show you the substitution. And then plus 3. All of these cancel out, guys, so you're left with 3. Yeah, that's it. Now let's do the 1. For the 1, we're going to do negative 1 and then we're going to square it, plus 1, okay, and then plus 3. You see the substitution? Now, be careful, guys, with this part right here. You got to square the 1, which is 1. So that leaves you with a negative 1 plus 1 plus 3. Negative 1 plus 1 is 3. So the answer, negative 1 plus 1 is 0. So the answer turns out to be 3. Shazam. Oh, that's another 3. Oh, okay. Well, very interesting. I know why it's happening, guys, but we're not going to talk about that yet. Okay. So here comes the last one, guys. We're going to substitute. This time we're substituting in negative 2. Now be careful, guys, with that power. You want to square this negative 2 first, okay? Don't just go in there and do negative 2 is positive 2. No. Okay? So next, guys, we're going to plug in the negative 2 over here, okay? And then plus 3. Now, negative 2 squared is positive 4. Okay, that's going to turn out to be a negative 4, guys. Yeah, negative 2 squared is positive 4. Keep the negative in front of the parentheses. And then minus 2, because plus negative 2 is minus 2. And then plus 3, we're going to work it out. Negative 4 minus 2 is negative 6. Negative 6 plus 3 is a negative 3, guys. So here's the answer. So, guys, that's evaluating the functions, okay? So let me go ahead and do this last one right here. And then I am going to stop because I don't want to do too much, okay, and overwhelm you guys. Now, let's go ahead and look, guys. G of x is equal to 8. Now, this one, they want us to find g of 5, g of negative 200, and then g of 7 minus 4x. Shazam. Okay. Now, guys, remember, g of x is the same thing as y. That's it. The same thing as y. And all of these values in here inside the parentheses represent x. All of them represent x. So this problem is saying y is always equal to 8. The function is always equal to 8. Regardless of what x is, the function will always be 8. Guys, this means we have a constant. It will never change, regardless of what x is. X is changing, but y is never changing. So therefore, whatever x value you plug in, you will always get the same y value. So guys, every single one of these will be 8. Shazam. Yeah, guys. So I think I'm going to stop here. And then I will take your questions in class. We'll go over the assignment together. And obviously, guys, we're going to practice a little bit more. So if you didn't quite get it, it's okay. We'll get it in the classroom. So until next time, everybody, bye.